If you use AI coding tools like Claude Cursor or OpenCode to write code, you have probably run into a frustrating situation. You ask your AI assistant about some library or framework, and it gives you an answer that sounds confident but is completely wrong. Maybe it tells you about an API that changed 2 versions ago, or suggests a pattern that nobody uses anymore, or cites documentation that no longer exists. This happens because AI models are working with frozen knowledge. Their training data has a cutoff date, and the software ecosystem moves incredibly fast. New versions come out, APIs change, best practices evolve. Your AI helper does not automatically know about any of this. This is the problem that a new category of tools is trying to solve. These are MCP servers, which stands for Model Context Protocol, and they are designed to give AI agents access to fresh, accurate information about your dependencies, instead of relying on what the AI happened to learn during training. These tools let your AI ask questions and get answers based on the actual source code of the libraries you are using. Today, I want to compare 3 of the most interesting options in this space. They are called btca, kinetic-context, and kctx. All 3 let your AI ask questions about libraries and get answers grounded in real source code rather than stale documentation. But they take different approaches, and understanding those differences will help you pick the right one for your workflow. Before we dive in, I want to acknowledge the lineage here. Ben Davis created Better Context, which was really one of the first tools to popularize this idea of giving AI agents direct access to source code for answering dependency questions. His work inspired an entire wave of similar projects. Christopher Kopic was among those inspired, and he built kinetic-context as a tribute to the concept. Eventually, he took the ideas further and built kctx as a more full-featured successor. So when you look at these 3 tools, you are seeing a line of evolution that started with Ben Davis's original insight. Let me start with btca, which you will sometimes see referred to as Better Context in the NPM registry. The easiest way to think about btca is as a codebase research tool with 3 main entry points: a CLI for local repo search, a web app for saved threads and cloud projects, and an MCP interface for connecting AI coding agents. The key insight behind btca is that instead of relying on documentation, which can be incomplete or outdated, you can ask questions directly against the source code. The tool uses OpenCode as its AI backend, which means it can read through the actual implementation and show you exactly how things work. One of the nice things about btca is that it gives you choices in how you want to run it. The cloud version lets you use their managed infrastructure, which means less setup for you. You can save threads, organize projects, and search code in the cloud. This is good for ongoing research, team context, and work you want to revisit. The local version runs entirely on your machine, which is great if you want to keep everything private or if you are working with proprietary code. The CLI lets you ask questions about local repos directly in your terminal. Your code stays on your machine. You add repos or directories, and you get grounded answers fast. Setting up btca involves configuring resources, which are essentially the libraries you want to be able to ask about. There is a helpful prompt you can paste into your AI coding agent that will scan your package.json for major dependencies, suggest adding each as a btca resource with sensible defaults, and create the config file for you. The integration works with a wide range of AI coding environments. You can use it with Cursor, with Claude Code, with Codex, and with OpenCode. The setup involves adding an MCP configuration to your project, and then your AI assistant can automatically discover and use the resources you have configured. Now let me tell you about kinetic-context. This was Christopher Kopic's first version of this idea, and it was explicitly inspired by Ben Davis's Better Context. The core concept is the same. You have an MCP server that your AI coding tool can connect to, and you can ask questions about dependencies. But kinetic-context has a different architecture. It is designed primarily to run in Docker, and it separates the concerns differently. The kinetic-context server handles package management and project configuration, and it relies on a separate OpenCode instance to do the actual code analysis. When you run kinetic-context, you are running two services. There is the kinetic-context container itself, and there is the OpenCode container that it talks to. The packages and projects are stored as JSON configuration files and cloned Git repositories in volumes that you mount into the container. This means kinetic-context expects a specific directory structure. You have your packages directory, where you put the library repositories. You have a projects directory where you define which dependencies belong to which project, and you have a config directory for the OpenCode configuration. The setup is more hands-on compared to BTC. You are managing the data yourself, which gives you a lot of control but also requires more setup. One thing that makes kinetic-context interesting is that it is focused specifically on usage questions. The documentation is clear that this tool is for asking things like, how do I validate forms with Zod, not for querying package metadata like what is in the package.json. This focus shapes the user experience. You are expected to create projects and associate specific versions of dependencies with those projects, and then you can ask questions in the context of that project. Kinetic-context also includes a web dashboard that you can access in your browser. By default, it runs on localhost port 7167. This dashboard lets you interact with the system, manage your projects and dependencies, and test queries. The web interface provides an alternative to interacting purely through the MCP protocol, and it can be helpful for exploring what the system has available and debugging issues. Now let me tell you about kctx, which is the newest and most full-featured of the three. Christopher Capek built kctx as the successor to kinetic-context, and it represents a significant evolution. While kinetic-context was essentially a Docker container that you managed yourself, kctx is a complete web application with its own database, authentication system, and admin interface. When you run kctx, you get a React-based web dashboard where you can manage packages, repositories, conversations, and settings. There is a CLI as well, so you can do most operations from the terminal if you prefer. The CLI commands cover things like logging in, listing and adding packages, managing repositories, creating and revoking API keys, and viewing and updating settings. The web dashboard runs on port 3001 in development, and in production, it is typically exposed on port 7167. The architecture has changed in important ways from kinetic-context. Under the hood, kctx uses Prisma with SQLite or Terso for data storage, and it has proper user authentication through BetterAuth. This means you can have multiple users, each with their own API keys for accessing the MCP server. The first sign-up automatically becomes admin, and there are admin and user roles. The MCP tools themselves are similar to kinetic-context. You have list doppelset dependencies and query dependency available. But kctx adds RAG-powered search as an optional feature. This means you can enable embedding-based retrieval, which can make queries faster and more accurate by enriching them with relevant code chunks from the source code. The system can also automatically pull public repositories before answering queries, which helps keep things up to date. There is also conversation history that gets saved and can be shared. One thing that is worth noting is that kctx is explicitly the successor to kinetic-context. The documentation calls it kinetic-context VD2, and it is meant to be the more polished, more feature-complete version. If you were using kinetic-context, the expectation is that you would eventually migrate to KCT. So how do you choose between these three? Let me break it down based on different use cases and priorities. If you want the easiest setup and you are comfortable with a cloud option, btca is probably the place to start. Ben Davis and his team have invested heavily in making the experience smooth. You can sign up, configure resources through their dashboard, and be up and running in minutes. The integration with multiple AI tools is well documented, and you have the flexibility to switch to local if your needs change. This is a good default choice if you just want the problem solved without thinking too much about infrastructure. The web app lets you save threads and organize projects in the cloud, which is nice if you want to revisit your research later or share it with teammates. If you want to own everything and run it yourself, and you prefer a simpler architecture than kctx but more control than btxa offers, kinetic-context is the middle ground. It is still Docker-based, but the setup is more manual. You are managing your own OpenCode instance, your own package volumes, your own project configurations. The web dashboard on localhost 2 7167 gives you some visibility into the system. This is appealing if you are comfortable with Docker and you want to understand exactly how everything fits together. It is also free and open source in a more traditional sense. You can look at every line of code, modify it how you want, and run it without any external dependencies on someone else's service. The trade-off is that you are doing more of the operational work yourself. If you want the most features and you are willing to take on some operational complexity, kctx is the answer. The web dashboard, the authentication system, the conversation history, the RAG search, the CLI, the auto pull functionality, all of these things add up to a much more capable system. But they also add up to more moving parts. You need to manage the database. You need to think about authentication. You probably want to set up proper backups. This is the tool for when you are serious about this problem and you want to build a real platform around it. The multi-user support is particularly interesting if you are thinking about team usage. One thing that ties all three together is the AI backend. Each one uses OpenCode to do the actual reading and answering. OpenCode is an AI code editor that can analyze repositories and answer questions about them. It is the engine that makes all of this possible. When you ask a question through any of these tools, what is happening is that your question is being sent to OpenCode, which reads through the relevant source code and generates an answer. This is fundamentally different from simple RAG approaches that might use embeddings and vector search. OpenCode is actually reading and understanding the code, which means it can handle complex questions that require understanding how multiple pieces fit together. There is also a philosophical difference worth considering. btca is offered as both a service and as local software. You can pay for the cloud version or run it yourself. Kinetic-context and kctx are purely self-hosted. This might matter to you depending on where you stand on the spectrum between wanting someone else to manage the infrastructure and wanting to own everything. All three tools are actively maintained, and they represent different points on the trade-off curve between ease of use and control. The good news is that the core idea, giving AI agents access to real source code instead of outdated docs, is proving to be valuable. All three tools are solving the same fundamental problem, and they are all getting better over time. The question is just which trade-off makes the most sense for your situation. If you want to learn more about any of these tools, I will leave links in the video description. Each project has documentation that can help you get started. And if you are already using one of these tools, I would love to hear about your experience in the comments. What has worked well, what has been challenging, and what would you want to see next? Thanks for watching, and I will see you in the next one.